Hey everyone, and welcome to another video. Today we are taking a comprehensive look at a highly effective tool in the ethical hacking and penetration testing space called WAF Hunter. Before we dive into the specifics, I want to emphasize that this video is intended strictly for educational purposes and for authorized cybersecurity professionals. You should only use these techniques on systems you own or have explicit, documented permission to test. Understanding how web application firewalls operate, detect traffic, and potentially get bypassed is a critical part of securing web infrastructure against real-world threats. So, what is WAF Hunter? It is an advanced web application firewall detection tool specifically designed for penetration testers and security researchers. When you are conducting a web application assessment, identifying the presence and exact configuration of a firewall is essential. WAF Hunter goes far beyond basic banner grabbing. It features an advanced detection engine that utilizes multi-method detection. This includes deep header analysis, content analysis, response code analysis, and advanced payload testing to accurately determine what defenses are in place. Furthermore, it performs detailed version detection to pinpoint specific firewall configurations, and it provides a confidence scoring system so you know exactly how reliable the detection results are. If you are operating on a red team engagement where discretion is critical, the tool also includes a stealth mode designed to significantly reduce your detection risk by employing advanced evasion tactics from the very beginning. In terms of scope, WAF Hunter offers comprehensive support with over 100 built-in signatures. This means it can readily identify major enterprise solutions like Cloudflare, AWS WAF, Imperva, and F5 Big IP, among many others. The tool benefits from real-time updates to its signature database, and if you are dealing with a proprietary environment, you can easily implement custom signatures. WAF Hunter is built for professional workflows. It supports multi-threaded scanning, allowing you to concurrently evaluate multiple targets and save valuable time on large-scale assessments. Once your scan is complete, you can generate reports in various formats, including JSON, XML, HTML, and standard text. The tool is managed through intuitive YAML or JSON configuration files, features an extensible plugin system for adding custom modules, and maintains comprehensive logging to ensure you have a detailed audit trail of your testing activities. All of these professional features make it an incredibly versatile addition to your security toolkit. Whether you are performing a routine vulnerability scan or a deep dive penetration test, having clear visibility into the defensive layers of your target is the first step toward a successful and thorough assessment. Now that we have covered the primary features and capabilities of this powerful detection engine, let us move on to the practical side of setting it up on your local machine. The installation process for WAF Hunter is straightforward, but you will need to ensure your system meets a few basic prerequisites. You must have Python 3.7 or higher installed on your system. To begin, we need to clone the project repository directly from GitHub. Open your terminal and type the command git clone followed by the URL, which is https://github.com/mrpasswordtz/wafhunter.git. Once the repository is successfully cloned, navigate into the new directory by typing the command cd waf hunter. Now that we are in the correct folder, we need to install all the necessary dependencies that the tool requires to function. You can do this automatically by typing pip install -r requirements.txt. This will fetch all the required Python packages. After the dependencies are installed, we need to make the main Python script executable. Type the command chmod +x wafhunter.py. To verify that our installation was successful, we can bring up the Help menu by typing Python 3 wafhunter.py-help. This will display all the available commands and confirm the tool is ready. With the installation complete and the tool ready for use, I want to spend the remainder of this video exploring the extensive, highly advanced bypass techniques that WAF Hunter can test during an engagement. As a quick reminder, I have not shown any practical attacks against live external targets in this video. We are strictly showcasing the tool itself, demonstrating the local installation process, and providing a comprehensive theoretical overview of its built-in evasion capabilities. Understanding these mechanisms is absolutely vital for any blue team trying to secure their perimeter or any red team trying to simulate sophisticated modern threat actors. The bypass modules within WAF Hunter are categorized into several advanced areas designed to stress test every aspect of a firewall's parsing engine. First is encoding evasion. Firewalls often rely on matching specific known malicious strings, so the tool automatically tests payload variations using URL encoding, Unicode, base64, hex, HTML entities, UTF-7, 16, and 32. It also tests octal, binary, ROT13, and hash obfuscation to see if the firewall fails to normalize the data. Next, it evaluates case variations by sending payloads in mixed case, lowercase, uppercase, title case, alternating case, and random case formats. Whitespace manipulation is another critical testing vector. The tool injects tabs, new lines, carriage returns, multiple spaces, zero width spaces, non-breaking spaces, vertical tabs, and form feeds to identify parsing discrepancies in the firewall rules. This is closely followed by Unicode evasion, which tests full width characters, zero width characters, homoglyph substitution, Unicode normalization, right to left overrides, combining characters, mathematical alphanumeric representations, and even emoji substitution. Moving down the stack, the tool performs protocol evasion by manipulating HTTP2 multiplexing, HTTP3 quick, and TLS versions, along with TLS fingerprint spoofing. It can simulate complex edge cases like HTTP pipelining, request smuggling, response splitting, and WebSocket protocol manipulation. For header manipulation, WAF Hunter tests custom user agents, header ordering, duplication, case variation, IP spoofing, referrer spoofing, host injection, and cookie manipulation. Timing evasion allows you to test connection handling through request spacing, burst requests, random timing, slow loris attacks, Rudy attacks, time-based evasion, session puzzling, and clock skew exploitation. The tool also features comprehensive obfuscation testing, utilizing string concatenation, comment injection, JavaScript, CSS, and HTML obfuscation, SQL comment obfuscation, polymorphic code injection, dead code injection, and code reordering techniques. Additionally, it checks for parameter pollution by evaluating duplicate parameters, parameter order variation, array parameter injection, and JSON or XML parameter pollution. It tests chunked encoding bypasses through chunked transfer encoding, chunk size manipulation, and chunk boundary obfuscation. Finally, it includes attack-specific evasion for SQL injection, cross-site scripting, and command injection, as well as advanced evasion techniques covering machine learning evasion, behavioral analysis bypass, fingerprint spoofing, CAPTCHA bypasses, challenge bypasses, IP rotation, and user agent rotation. To see these techniques simulated locally, you can run the showcase script by typing python3 demo_bypass.py. This allows you to explore the tool's capabilities safely on your own hardware. This tool provides an incredible amount of value for anyone deeply involved in the offensive security or defensive engineering fields. It truly highlights the importance of not just deploying a firewall, but properly tuning it against modern evasion methods. That wraps up our overview of WAF Hunter. Thank you so much for watching. Keep learning, stay ethical, and I will see you in the next video.